And under fractions, really what it says regrouping in our modern world, we call that borrowing. We will look at one example where we do it long and the hard way, and then we'll just do it the right way. If you have 5 1/3 minus 2 2/3. First of all, anytime we have fractions, we do what? When we add and subtract them, we write them up and down. So it's going to look like this. If you actually did some picture representations of this, notice what you're starting with. You're starting with 5 whole circles plus 1/3 of another circle. And from that, I am taking away 2 2/3. So I know I'm taking 2 whole circles away, so I'll remove those. Okay, and now I need to take away how much more? 2/3. Well, this only gives me 1/3 of those 2/3. So what am I going to have to do? I'm going to have to take one of these, split it into thirds, so I can get my other third. So I take away this third plus a second third. What am I left with? 2 whole circles plus 2/3 of the other one. So I know my answer should be 2 2/3. But I don't want to have to draw circles, especially if you're doing like 675 and 5/18 minus whatever. So we do it just like normal subtraction. You have to look at this here and go, okay, I cannot take 2/3 away from 1/3, so I have to borrow. This becomes a 4. Now, here's where people go make mistakes. In normal subtraction, when you borrow, you just put a 1 up there because it stands for 10. But you don't make this an 11, okay? That is not what you do. When you borrow from the 5, you're taking 1 away from that. So I'm actually adding 1 to this. Well, when I'm adding 1 to a fraction, what do I have to do? I have to make this a fraction. 1 is what fraction? Well, 1/1 I can't add to 1/3. There are an infinite, if I have the number 1, I can make gazillions of fractions that equal 1. One of them is 1/1, I get 2/2, I can do 3/3, I can do 4/4, I can do 5/5, I can do 6/6. Which one, what do I want to have my 1 be when I add it to this 1/3, Sam? Yeah, you want this 1 to be 3/3, because that's the same as 1. If I add 3/3 to 1/3, I get 4/3. Now, and then I can do 2/3 from 4/3, which gives me my 2/3, and 2 from 4, which gives me 2. But you don't have to do that every time, because there's one simple little rule that you follow when you borrow with fractions. Anybody know what it is? How do I get my new top number? Look at my new top number was 4 here. Look at these 2 numbers. If I just had those 2 numbers, what would I do with those 2 numbers to get a 4 on the top, Nathan? You would just add them together, and that's what you do. And that's something we'll write down. When you borrow, you add the denominator and numerator, those are the top and bottom, for your new top number. And remember, you're not changing the bottom. You keep the same bottom. Running out of room. Okay, you keep the same bottom. Let's look at another example here. Let's say you've got 7 5/8, and I'm subtracting 3 7/8. Now please understand, you don't always have to borrow. If this bottom would have been smaller than a 5, I didn't have to borrow. So don't get it in your head that every time you have to borrow. I see people do that. Once we start borrowing, they think they have to borrow on everything. That's not the case here. But this time I do. I cannot take 7/8 from 5/8, so I need to change this fraction. I borrow from the 7, it becomes a 6. And the rule simply says this: to get my new top number, it's not 15. I don't just put a 1 there. I add 8 plus 5 together for my new top number, which is 13. Add these 2 together, new top number. And then 7 from 13 is 6. And 3 from 6 is 3. Ladies and gentlemen, when you subtract fractions, and I do have to change that to 3/4, when you subtract fractions, you will never, ever, ever get an improper fraction over here. If you do, you did something wrong. You know, if I would have got 9/8, that would be, you can't do that. There's no way you can subtract two fractions correctly and get an improper fraction. You can get a fraction that needs to be reduced, which this is, but you will never get an improper fraction. Good point, sir. Let's carry on. How about this? 17 3/5 minus 12 4/5. I'll let you do that. Tell me what the answer to said differential problem would be. 17 3/5 minus 12 4/5. God bless you, and again. If we do the math correctly, Addison, what'd you come up with?
4 4/5.
4 4/5. Let's see if that works out. Oh, I do have to borrow. This becomes a 16. My new top number is what I get when I add 5 plus 3 together, which is an 8. The bottom number stays the same. 4 from 8 is 4. I keep the same bottom. 4 says 12 from 16 is 4. Everybody's doing well so far. Let's do an extremely difficult one. How about 9 17 65 minus 4 and 49 65. That's a beautiful one if ever I saw it. 9 17 65 minus 4 and 49 65. Answer. Sam says
4 and 64 65.
I don't know, that doesn't sound quite right, but let's try. Maybe this. This becomes an 8. What'd you get, Sam, when you added 65 plus 17? 65 plus 17?
Oh, I did it wrong.
Should be 82, I believe.
I accidentally added
49 from 82, and maybe you have to do that off to the side. I don't know. Yeah, you get 33 65. And 4 from 8 is 4. How many folks got 4 and 33 65? Got it. I think you've probably got a firm grasp of reality.